Hey guys, I hope that you are having a great 3-day weekend. This is just going to be a short review going through all the concepts that are on the test. Instead of going through all the questions on the suggested review, I'm just going to go through one or two from each section to make sure that you're feeling okay on it. So the first one that I want to go through is number 1, and this is just helping us find the slope through a line. So just a reminder, the way that I need to do this, I'm going to be using the formula m equals y2 minus y1 over x2 minus x1. So it doesn't matter if I use this as the first ordered pair or this one as the first ordered pair. I just need to be consistent. So I'm going to use this as the first one and this as the second one. So I'm going to go ahead and write 2 minus 2 equals 8 minus negative 3. So I get 0 over 11. And the two kind of weird situations we run into with slope is when we have 0 in the numerator or if we have 0 in the denominator. Remember that whenever I have something like 0 over 11, that is just equal to 0. And just a reminder, what that would look like is a horizontal line. If I get something like 11 over 0, that's when we would have no slope. And that would be a line that is going up and down a vertical line. We also see no slope written as undefined. So that's how we go ahead and find the slope between two different points. Okay, so in the next section, it's talking about point-slope form of the equation of a line. And to be honest, I really don't care if you know point-slope form. We just need to be able to write it in an equation. So I'm going to go ahead and use slope-intercept form. And just a reminder that if you guys need extra help on any of the odd problems on this assignment, you can go to Calc Chat, which I have linked on the Webliography in Myo Studio, and that will go ahead and give you worked out solutions. So looking at number 11, I'm going to start by writing y equals mx plus b. We already know the slope, so I can go ahead and substitute that in. Now, in order to know the equation of the line, I need to go ahead and just figure out what b is. So I'm going to substitute in 0, negative 5 for x and for y. So I have negative 5 equals 3 halves times 0 plus b. So negative 5 ends up being our y-intercept. Some of you may have seen this in the fact that 0 was our x value here, which means that this is the y-intercept already. But if you weren't really paying attention, this would give you the same answer. So I'm going to write my equation, y equals 3 halves x minus 5. This is the equation of our line. If I needed to find any other point on this line, I could substitute any x value in, and it would give me a y value. So x is my input, y is my output. For example, if I went ahead and substituted in 2, if I put 2 in, I would get 3 minus 5, which is negative 2. And I could do that same thing to find different ordered pairs, and there are a bunch of different answers we could give for that portion. So the next section gives us two different ordered pairs, and we need to go ahead and find the equation of the line that passes through them. So we need to start off by finding the slope. So just like in the first section, I'm using the formula m equals y2 minus y1 over x2 minus x1. So I get 2 over 7 as my answer. So I can write y equals 2/7 x plus b. The next thing I need to do is substitute in either one of these ordered pairs for x and y to give me what the b value is. I'm going to choose this one because I think it looks easier, but it doesn't matter which ordered pair we use. So substituting in negative 1 and 0, I get 0 equals negative 2/7 plus b. So 2/7 is equal to b. So my equation is y equals 2/7 x plus 2/7. Now remember, if the test is multiple choice, if the actual answer is in a different form, you can manipulate the equation by moving x over, by multiplying by 7, and you could find the answer that matches this form of the equation. 25 just deals with taking real-life information and being able to write an equation. So if we look at this, v, the value, is equal to the slope times the number of years since 2010 plus the y-intercept. So in this case, since t is the number of years since 2010, b would represent the value in 2010, which actually is given to us. The information in the book tells us that in 2010, 12,500 is the 2010 value, and that there's an increase of 850 per year. Normally when we see rate, we know that's like a slope because it's increasing per year. So this would be the equation we would use in order to represent this change. Now if we wanted to find a specific value, like if I wanted to know what is the value in 2012, I could figure out how many years have passed since 2010. So in that case it would be 2, and I would substitute 2 in for t, and it would give us the value at that point in time. Okay, 32 has to do with parallel and perpendicular lines, and a lot of you struggled with this on our quiz. So the first thing I'm going to do, I'm actually going to go ahead and rewrite this equation into slope-intercept form. So I get y equals 5/3 minus 2/3 x. And honestly, all I care about here is that negative 2/3 because that is the slope. We know parallel lines have the same exact slope. So to find the parallel line, I'm going to write y equals negative 2/3 x plus b, and I'm going to substitute in the ordered pair that's given to us. So when I substitute in 3 and negative 8, I get 3 equals 16/3 plus b. I would subtract 16/3 from both sides, and I get that the y-intercept is negative 7/3. So that tells me that the equation of the parallel line would be y equals negative 2/3 x minus 7/3. Now the second type of problem that it's asking us to do is find the perpendicular line. I know perpendicular lines are opposite reciprocals. The slopes are opposite reciprocals. So I'm going to start off by writing y equals 3/2 x plus b. Because this time I'm taking negative 2/3, I'm taking the reciprocal, which means I'm flipping it, and just changing the sign. So now I'm plugging in negative 8 and 3 again, and when I go through the algebra, I get 15 is equal to b, so my equation would be y equals 3/2 x plus 15, and that would be the slope, or the equation of the line perpendicular. So remember, parallel means I have the same line, the same slope. Perpendicular means I have the opposite reciprocal. So the next section is talking about testing for functions, and it's asking which set of ordered pairs represents a function from a to b. That means that a is like our input and b is our output. We know in order to be a function, it needs to be 1-to-1, which means for every single input there can only be one output. So if we look at set A here, I can see that there's two different ordered pairs that both have an input of 20 and have different outputs. So we would say that that is not a function because 20 corresponds with two different outputs. If we look at part B, the inputs are 10, 20, 30, 40. Notice it doesn't matter that they all have the same output. Okay, they can all have the same output, that doesn't matter. Every single input has a different output. So for 33, we would say A is a function, A is not a function, B is a function. The next section deals with evaluating functions. So remember, this is our input. So if I have an equation, whatever is inside our parentheses is what we're substituting in for x. So A says f of 1, so I'm going to write 1 squared plus 1, which is 2. For part B, this time we're putting negative 3 into x. So I would have the quantity negative 3 squared plus 1, which ends up being 10. So the whole idea here is whatever's in the parentheses is what I'm substituting in for x. And if we look at C and D, they try and get a little tricky on us, but it doesn't matter that I have variables in there. I'm using the same exact idea. So I'm replacing x with b cubed. So I have b cubed squared plus 1. I know when I'm taking an exponent to a power, I multiply those. So I end up getting b to the 6th plus 1. And then if we look at D, I need to go ahead and substitute in x minus 1 for x. And I know whenever I have a binomial that's squared, that means I need to FOIL that. So I get x squared minus 2x plus 1 plus 1. So our answer would be x squared minus 2x plus 2. So that is how we evaluate functions. For 47 and 49, we need to find the domain of the function. So remember, domain means all the x values that will work of this function. So in problems like this, when we have an equation, we really need to use common sense and look at the different types of equations. This equation, we have a denominator. We know that we can never divide by 0, so I need to figure out which values are going to make this denominator 0. So I'm going to set x plus 2 equal to 0, so I get x equals negative 2. That means all real numbers except for negative 2 will work. So if I'm writing this in interval notation, I know it will go from negative infinity to negative 2. Remember, we use a parenthesis to show that negative 2 is not included. Union, negative 2 to infinity. For 49, this time I have a square root. We know that we cannot have negative numbers inside a square root. So if I'm going through this, I'm setting whatever's inside our radical equal to 0, and I get plus or minus 5. So I'm actually going to go ahead and graph a number line here, just so I can tell which values are working. So I'm going to try and substitute in a number that's in between, like 0. So if I put 0 in here, I get 25 minus 0 squared. That works. If I try a number that's either less than negative 5 or greater than 5, for example, negative 6, I get a negative number inside, which is not okay. So that tells me that all of our answers are between negative 5 and 5. I'm using brackets here because it is okay to have 0 inside our radical. Okay, and just to make sure we're okay on why we didn't shade out here, if I substituted in negative 6, I would get 25 minus 36, which is negative 11. That would not work. For the next section, it's asking us to find domain and range of a function. So the equation was f of x equals 3 minus 2x squared. So I went ahead and graphed this in my graphing calculator, and I took a picture of what it looked like. We know domain means all the x values. Even though it appears to stop, we know it's really like there are arrows that continue. So we would say our domain goes from negative infinity to positive infinity. That means that I can input any x value and it would work and give us a y value. For our range is a little bit different. If I look at this problem, I might notice that it doesn't appear to go above this line. And if we look carefully at our calculator, that actually is at 3. So I can say that my range is from negative infinity to positive 3. At positive 3, I need to use a bracket because it is a solid line there, so positive 3 is included. We may also notice that in this case happens to be our maximum value. We call this a relative max because it's the highest point where it's decreasing on both sides. Make sure you guys have your graphing calculators for the test because it will make your lives much easier, and some problems you really will not be able to solve without graphing them. Now I want to talk about the vertical line test. So number 65, the graph is given to us and it looks something like this. Now we know the vertical line test is if we go through with a vertical line through our function, it should only touch one point at a time in order for it to be a function. We can tell that this fails, this is not a function, because at this point, at this point, at this point, we can really find a ton of different points where it's touching two different places at the same time. So we would say this is not a function. The next one, we need to figure out the open intervals on which the function is increasing, decreasing, or constant. So the very first thing I did was graph this in our graphing calculator, and this is what our graph looks like. Now, if we're starting right away, it looks like our function is increasing because it's rising from left to right until we hit this value, which actually we call a minimum. A maximum. This would be a relative maximum, this would be a relative minimum. So in order to figure out the interval, okay, I'm going to say it is increasing. So if I'm going through this, okay, in order to find the max, remember in our calculator we would press second trace and we would choose the option maximum. It'll make us choose a value to the left and a value to the right. And then put a guess in the middle. So it tells me that my max is -1, 2. Okay, I'm going to right away find what the minimum is as well. So I'm going to do second calculate. Maximum is option 4, minimum is option 3. I need to choose a point to the left, a point to the right, and a guess in between. If you guys need more practice on that, remember that we have that whole worksheet on finding mins and maxes that can be helpful on the calculator worksheet. The minimum gives me 0.99999, so I'm going to round that to 1, -2. So whenever we are talking about increasing or decreasing, I only care about the domain. I only care about the x values. So if we look, it is increasing until I hit an x value of -1. As soon as I hit -1, it starts decreasing until I hit an x value of 1. At that point, it starts to increase again until we hit infinity. So this would be our answer right here. And the things that I want us to get out of this, the big thing we stressed in our notes is domain, domain, domain. So increasing, decreasing, constant. Remember, constant would be if it looked like it was a horizontal line. We always look at the domain. I don't care about the y values. The second thing is just remembering how to find a minimum and maximum in our graphing calculator, so definitely practice that at home. Now I'm going to skip to one like -70, or not negative, number 79. So it's f of x equals x squared plus 6. And this is, the directions ask us to determine whether it's even, odd, or neither. And we talked a lot about the graphs and what the symmetry of the graphs look like to know if it's even, odd, or neither. The other thing that we looked at were the exponents. We said if all the exponents are even, and that includes constants, then it is an even function. If all the exponents were odd, and in those problems we could not have a constant, that means it is an odd function. And if there's a mix, we would say that it is neither. So in this case, I would say this is an even function. Moving on to describing transformations. We spent a lot of time, remember we did that kind of practice quiz, and we did an activity on knowing what the equation is doing to a graph. So if we look at number 99 here, the directions are actually just telling us we want to describe what it's going to look like. Okay, so I'm just going to go through describing what this is going to look like. We can see the parent function is x cubed, and that looks like our little fun squiggle. That looks like that. But the two things that are really different here are these two numbers. So we need to remember, whenever I have something inside the function, that is going to be a horizontal shift, and in this case, it is a horizontal shift to the right 2. Because this number inside, we always do the opposite of what it tells us. This number up here tells us a vertical shift. Since it's +5, that means we are going up 5. So in addition to these two types of transformations, we talked about negatives being reflections. We also talked about vertical stretches and vertical shrinks, and that's when this number out in front changed, when it wasn't just a 1. So definitely look through your notes, look through that 42 graphs, and especially that other set of notes we took with the graphs when we actually came up with the equations. Okay, next is just talking about combinations of functions, and I'm going to start with a basic one. Remember, we said we have addition, subtraction, multiplication, division, And then the tough one we dealt with was composition. But one like this can be a little bit tricky, and we tend to miss things like this on the test, so I want to go through it. First of all, I have f in here, so that means I have 4 in here, so that means wherever we have an x, I'm going to put a 4. So, function f is 3 minus 2 of x. Instead of x, I put a 4 because a 4 is right here. Minus g of 4. So I'm using g of x here and putting a 4 in the place of x. Now it's really important to put this second function in parentheses, especially when we have subtraction, because I know I might have to distribute. In this case, I just have one term, so that doesn't matter. But if it was like x minus square root 4, I would need to make sure to distribute the negative to both of those, and that's something that I would expect to see on a test. So if I actually go through this, I have 3 minus 8 minus 2, so negative 5 minus 2 is negative 7. So now we're going to go through composition. And just to review with composition, this is just like if it said h of g of 5. So I am always starting inside. So I need to figure out what is g of 5. So g, remember that's telling me the name of the function I'm using, which happens to be this function. 5 is our input. So wherever there's an x in the function, I'm replacing it with a 5. So now I'm going to write h of, and we actually figured out that g of 5 was equal to root 5. So this means now I'm doing h of root 5. H refers to this function, so wherever there's an x, I'm replacing it with root 5. So I have 3 times root 5 squared plus 2. So composition is just a fancy way of saying substitution. So when I square that root 5, I get 5. 15 plus 2 is 17. Now if they gave us a problem like this, and it just said x instead of 5, then I would just leave this as root x and substitute root x in wherever there was an x. And the last problem that I'm going to go through is 127, and this is talking about inverse functions. So first it tells us to find the inverse function informally, and we refer to that as switch and solve. Now I know f of x represents y, so I can just write x equals 1/2 y plus 3. So I need to go ahead and isolate y. So I'm going to multiply everything by 2. So I get 2x minus 6 is the inverse of f of x. So that would be our first step. Now we need to actually prove this. We call this verifying that things are inverses, and we do this using composition. So I'm writing f of 2x minus 6, because all I did was replace whatever was inside, we know that's our input, with what the inverse was actually equal to. And this means that in function f, wherever there's an x, I'm replacing it with 2x minus 6. So I have 1/2 times 2x minus 6 plus 3, which becomes x minus 3 plus 3, which is x. And if you guys remember, we did learn that whenever we find inverses, when we do this composition, it should end up equaling x. Now I need to do the opposite way, where my input this time is actually our original function, and I'm inputting that into the inverse. So I'm going to write the inverse of 1/2 x plus 3. So I'm inputting that in wherever there was an x. So in this case, it's 2x minus 6. So I'm going to write 2 times 1/2 x plus 3 minus 6. When I distribute, I get x plus 6 minus 6, which is x. So I have proved and verified that these indeed are inverses of each other. So I just went through and did a little bit from each section. Hopefully this helps get you on the right track. Remember, we are going to review the first half hour of class, and also you guys can use Calc Chat to help you on some of the odd problems that I did not go through. Keep studying those suggested problems, the quizzes that you guys have and your homework, and you should be in good shape for this test. I will see you guys in class.